You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Hey everyone, great to have you here for another recording of The New Stack Makers. And my guest today is Mark Hinkle. I've known Mark for years, and I want to first say that Mark is one of our most successful contributors at the New Stack. So thank you, Mark, for that. I really appreciate it.
Sure.
You've written some I don't know how to describe it, posts that get people interested in the topic. Well, maybe we could go in a little bit more on that as we go, but you just have that knack. So that's always nice to have someone contributing who has that knack. You recently found an email newsletter company. I'd like to hear a little bit more about that, which is focusing on AI. You're also doing some consulting. And I'll give you the floor to talk a little bit about that. But first, I just want to say what we're going to talk about. We're going to talk about how we think about serverless functions when looking at them at how they compare, in some respects, philosophically, to AI agents. And I started thinking about this last night after I got back from the baseball game. That wasn't a baseball game; it was a basketball game. Saw the Trailblazers lose to the Lakers, but that's another story. And I thought, gosh, there is this similarity between serverless functions and AI agents. And I'm curious what Mark thought about it, because among all the other things he's done, Mark was also CEO and co-founder of TriggerMesh, which was a serverless company. Was funded by Index Partners and Cisco. And today, though, he's really focused on AI agents. And I know he has an overarching view on this, but I'm curious about that comparison. I would love to just get his take. So, Mark, thanks for joining us.
Hey, thanks for having me, Alex. It's very, it's going to be hard to top that intro, but I'll do my best. But yeah, my MO is I have been in the forefront of early technology trends for the last, and now that I say 30 years, it makes me feel really old. But, I started out for one of the first national service or internet service providers in the 90s, and it was really successful and fun. And then I did open source systems management, early cloud.com, and then serverless, and now AI. So I'm always, I think I realized that I was a terrible student when I was younger, and I love learning as I'm older when it's something I'm interested in. So as you mentioned, I was really interested in serverless. I was really interested in cloud, and now I'm really interested in AI. And anytime I can work on something and learn is much more satisfying to me. And then I like to share what I learned. So I think that's maybe part of my secret sauce to get people engaged around new technology when we write about it. But
yeah. So let's talk about serverless functions and AI agents. And they really reflect this shift. Both of them, I think, a shift in how we view computational entities without, thinking of a better way to describe it. And I know you have some perspective on this topic, and I'm curious on how you view, this concept of what we think of as computations, because traditionally it's been bound by persistence and state.
Yep.
And that's not the case with serverless capabilities in AI agents.
Mm-hmm. Well, yeah. So I think serverless, the big reason we moved to serverless is that persistence means that you are constantly consuming resources, so power and CPU and memory. And serverless was great because you could just, only as you're executing a task, be consuming those resources. And then companies like Amazon and Google could over-provision their servers. We got cheaper compute for the amount we paid on a per usage that was less than a dedicated hour. And Gemini and Amazon had better margins because they could run more customers on those things, and it worked out well for everyone. But and the key was that we were saving the amount of compute time. now, as we get into this era where GPUs are the most precious commodity in the sort of hardware stack, and soon the second most one that we're going to see, I believe, is going to be a blocker, is going to be high bandwidth memory, so DDR3 memory. So when you aren't dedicating that resource 100% of the time, and you're only running on use, that'll help the scaling there. And finally, the sort of frontier is how effective will serverless functions be on the GPU side, and how practical is that? Which, where I see it when we talk about agents, these agents are goal-oriented pieces of code. So rather than when we put in ChatGPT and it's question and answer, when you use an agent, you usually have a goal in mind. I am going to, query a database and send an email at a certain time, and I'm going to add the insights that are available by using a large language model like OpenAI's A03 or IBM's Granite open source models, or Meta's Llama. And so you have sort of the agent that's just sort of going to be a task worker, and then you have the model. But we blur the lines where some of those algorithms, those AI algorithms, will they be executed as discrete bits of code, or processes, I should say, rather than sucking up GPU resources and memory 100% of the time.
So you mentioned two things that piqued my curiosity. You talk about the memory, and I'm curious on what your take is on memory and how it relates to this question about AI agents and serverless functions. And then you also mentioned the GPU and the functions in the GPU. This leads to me to questions about the networking too.
Yeah. So, I mean, networking is a big piece of that, and NVIDIA has come up with some new networking standards that allow massive amounts of data to come in and out of the large language model. So those NVIDIA interconnects are important. And, pretty much every time you have a new, information heavy fire hose that you want to drink from, whether it was storage back in the day, we went from, copper connects to fiber connects. We went to, higher levels of networking. But let's start with the first question was on memory, and then we'll go into GPU, and then we'll go into maybe a little bit more of the networking, because I think that they all sort of connect. So when you work with a large language model, they have a context window. So that's their short-term memory. So if you and I have a conversation at a cocktail party, that conversation is like a conversation with ChatGPT or a large language model, where the longer the conversation goes, we may remember more of the things at the end of the conversation than we did at the beginning. If we talk for an hour, we're probably going to have a clearer memory of the last 10 minutes than we did of the first 10 minutes.
Right.
But the reason that memory is important and DDR RAM is important is that helps hold the context window for these large language models. So when we started out with like ChatGPT, we're looking at a 4K language or context window. Now, some of these models have, by default, I think ChatGPT Pro might be 128K for Pro and 32K for the regular ChatGPT. And Gemini has 1 million token context window. And a token is roughly, there isn't a great translation, but what happens is words gets broken down into these tokens, and the tokens are how the model measures the amount of text in the buffer. And so, 100, if you divide by 3, that's the number of words, is a rough calculation. So that's the memory. And then the GPU is executing the algorithms for the large language model, and that's the thing that's in the news all the time. And
Right.
2 weeks ago or 3 weeks ago now, I guess DeepSeek made news because they were showing how efficient they were with their large language model, and it's sort of it's like anybody coming from a nation state that's controlled by a government that censors. I'm sure that there's some details that weren't left out, but it really the things that they did share were really interesting about how the way that OpenAI and Google were doing prediction in the model was they were looking at one token at a time and predicting the next. And what DeepSeek did was they looked at a group of tokens and predicted the next group of tokens, and that allowed them to really get some efficiency. There were quite a few other things. There are like 4 major geeky things about DeepSeek that they shared, and all of those innovations will probably filter down throughout the whole industry to make large language models usage on GPUs more effective. One of the things they did I thought was particularly interesting was there is a middleware in NVIDIA GPUs called CUDA, C-U-D-A.
Yeah.
And it is proprietary to NVIDIA, and they did something that I want to say it was IPX. I'm terrible with these acronyms, but basically it allowed them to go right to the metal without using that intermediary area. And the reason for that is technically there's a ban on NVIDIA shipping to China so they had to find a way to standardize across all these bare metal. In hindsight, they probably bought a bunch of those GPUs from a third party, and they understated how many they had because of the trade sanctions. But that's some of the things that they did do are bar none going to improve the ability for us to use GPUs. And then the final thing is just the networking. So when you're trying to analyze large bits of data, the choke point, if you want to take a data lake and you're using Databricks or someone like that and want to analyze that, you could be sending millions of records for credit card fraud. You could be sending all sorts of data, and the choke point will be how much data you can send to the model at one time, because I don't know that they've have a lot of parallelization in their model or not. It's sort of a black box to me, but I would assume that allows you to send more data without having to be quite as you would have to parallelize it the same way that you would a web server. And then would you have the ability to analyze the collective amount of data or not? Or you'd have to share it?
One question I have when I started researching this topic is when I was looking at the distinction between serverless functions and AI agents is this question of agency. And, the serverless infrastructure does abstract, functions do abstract the infrastructure, whereas, as I understand it, the AI agents really abstract the algorithms. So you can do those complex tasks and, those complex queries. And I'm curious, and does the algorithm then abstract the infrastructure itself? And so what is the role of the agent itself? Is it a kind of a superseding capability that will kind of oversee the serverless capabilities, or does it make serverless capabilities more irrelevant?
I think that if we think about the agents as almost dumb robots, think of them as chopping wood and carrying water. So they would be exchanging data, or they would be, querying an API and things like that. But the brain for those, I think they will still call back to the large language model itself. So the workers, the dumb robots, will probably be serverless functions. So it might be something written in Python or JavaScript that does stuff. But the agent itself, I think, will still be querying through an API, a large language model, and not executing the general model, but they may have smaller bespoke models. So say you are in a data operation, you may have serverless agents that query a large language model or small language model. I call them slim. Just that's really good at one thing. So maybe you would have a language model that is really good at ETL, extract, transform, and load, taking data from one format to another. You might have a small language model that's really good in the business that you're in as, copy editing. So you get a lot of inquiries. You might have them sort and copy edit, and you may have, trained them on your style guide, or you may have a business development rep that is very, has an agent that queries a model that has tons of opening lines for them to do email outreach and responses, and is smart enough to decide which one is the best. Just like you'd have an employee, you'd train them on your procedures. And then the nice thing is that you can make these language models, force them to be reflective on the results and keep getting better. Where you can ask an employee to do that, but it's hard to force everybody to be a top performer. So that's the sort of distinction.
The top performer question.
Yes. Is like or I shouldn't say a top performer, is consistent performer that never needs a break, that never gets thick. So if you have a human sales development rep and you have an agentic sales development rep, that agentic sales development rep can work 24/7, not need a break, and you can correct their behavior pretty well. But if you have a human, they may be exceptional at creating repertoire, but they can only work 8 hours a day. They probably are not nearly as efficient because we just, we get tired. We need lunch. We need a break. We need to socialize. So I think that you can make these AI agents in the short term. They will be, they'll work longer and they will work harder just because they don't get tired, but are probably not nearly as capable as a top performing human. But over time, they'll get better and better. Just like when you train a human worker, you'll train your agents. They'll get better and better. And before long, eventually they will get there. So
when you think about that, that does reflect on, in some respects on the current questions we have about AI from an ethical standpoint. But they also reflect on the crises that we see, not just in AI, but in open source, right? Where what we're talking about here, with these evolution of these agents and this evolution of their capabilities and to do very complex tasks, that means then we see a much different kind of view on how we think about data and code. And that seems to be really tripping up open source right now. Do you draw any analogies when you start thinking about these boundaries between code, infrastructure, and service? And it seems to be impossible to speak to any beginning and end with this kind of stuff, where essentially persistence does not exist. Because what you're saying is basically, hey, just ask it to do something, it'll do it forever.
Yep. I do think that we will get to a point where a lot of the Satya Nadella from Microsoft says software is dead, agents are the future, as he's been quoted saying that. I think what he means by that.
Who said that?
The CEO of Microsoft, and I always mess up his pronunciation. Yeah. But I think what's going to happen is Satya. Yeah, sorry. What we will see is a lot of these large language models are going to auto-generate their own tool set, and they will be bespoke rather than like something common like we see with HashiCorp in their, cloud space, or we would have seen with Chef or Puppet in the configuration management space. I think that they will generate tooling that is specific to the task, and they might do that on the fly. They may do that and have a almost the ability to call functions that are serverless, or may just be persistent for CI/CD loops or monitoring or things like that. Or observability and evaluation are the two terms that are getting popular because of AI. So I think that that's where software is going. Chamath Palihapitiya of Social Capital, he has this 80/90 company that is rating software that he thinks has 80% of the functionality of the leaders in the space at a 90% discount of what they would charge. So that's an interesting thing. But you also talked about the open source. Here's the thing that's really interesting about this is AI isn't great at everything, but one thing that it's very good at is coding. And I think that's a artifact of having all this open source software out there to use as training data. I think that that will continue to be of value for my previous point about generating tooling on the fly. It will look at all the open source software and say, here is a tool and it's pretty good, but we can just, adapt it. The open source value prop of being able to adapt it to your needs has always been spoken about widely, but used narrowly. Like a lot of people just use the core, and 2% might actually alter the software for their needs. Now we'll have these large language models that will probably take software like that and do exactly what we said we could do, because the ability to create code that is usable and do it very quickly is a core capability of these language models.
When you think about that, then I think also though about you talked about kind of the role that agents have and how they can increasingly do things on a 24/7 basis, and they'll get better and better at what they do. So what is the being in all that? What is the computational entity itself? When you start thinking about how you perceive these new developments, do agents encompass a different form of abstraction? And how, where it's like not the computational being is not stated anymore. It's not presence. It's a deeper type of almost something that's entirely ephemeral, where it's only the response that matters. And how does that impact technologists?
I think that is a big remains to be seen. Like, I think for the short term and the midterm, there's agents are going to look a lot like serverless functions, containers that are either persistent or ephemeral. But, we think we know how we design these large language models, but they continue to surprise us with what they do. The whole, creation of the GPT was because they let the training function run longer than they normally did. Usually what happens is something called overfitting. And at some point, if you keep overtraining the model, it creates more errors rather than eliminates it. But then there was this breakthrough where it just got better after it went through that. It dipped and then it got markedly better. I think that's sort of how these assets will be. Is we'll try and use the things we understand: serverless functions, containers, cloud native infrastructure. And then I think that the models will start to develop patterns that will probably be a little different than that. But I have no idea how it's a black box to me. Every time I watch a response and I've been doing this for almost 2.5, 3 years now. Every time I see a response to generative AI, I'm like, a little kid watching cartoons. I'm always fascinated because it continues to surprise me. I feel like that might be the way that our infrastructure will evolve. Or maybe that's a better question for the smart people at Berkeley and MIT and Stanford.
Yeah. Then perhaps on taking it back a little bit, what would you say to technologists who are managing AI agents? And thinking about that in the context of how they've managed serverless functions, which serverless environments are very common now.
Yeah.
So how do you think about managing AI agents themselves, and where do you start, and how do you build upon that that knowledge?
Well, I think it's really a matter of the interface is changing from code to natural language in general. And I've been playing around with a lot of these agents, and a lot of them are using natural language to control the agents, even though they have workflows. So I think that's what it's going to be like. Is your technologists are going to manage a team of virtual employees almost in the same way that they would manage a team of technical employees. So, they will say, we need you to, create these reports in a certain time frame. This is the data that needs to be on the report, and then we will continue to give them feedback. I think that's where, whether you're writing code or you're managing agents, is going to be your ability to specify the output in a way that gives you consistent quality. So, if you don't give an example to an employee of what the report looks like, they're going to use their best judgment, which could be great or could be terrible. The same thing would go for a AI agent. Is if you give them example, for example, if you want, if you had a style guide for the new stack, for example, and you're using an AI agent to copy edit and to check and do the research to fact check and verify, you would teach it what you would use for that. So maybe you would not want to fact check a story based on a Reddit thread from Saturday night tequila drinker versus going to the New York Times or Wikipedia or some other scholarly source. Teaching all of these agents what the right process and outcome is going to look a lot like what we do for technical workers today.
Well, thank you very much, Mark, for taking some time to talk. It's always fascinating to hear your takes on these types of topics. Mark, I really appreciate your time.
Oh, it was great talking to you. Thank you very much. And I think I'm going to see you in Raleigh in a couple of weeks, so that'll be exciting too.
Okay, take it easy.
Cheers, buddy.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.